Okay, I really want this programming video to work out, and I really hope it does, because this is an amazing achievement for my computer programming. And I've said that before, and I've shown you incredible things like my Sokoban game that I started making and never finished, and my infinity checkerboard that I made using SDL. But what I did this time took a long time, and it doesn't look very impressive to just a person running the program. It doesn't look very impressive because they've seen my spinning polygon animations before, anybody who follows me. So they think a spinning polygon, there's nothing exciting about that, right? Well, maybe not to them, but to me it's very exciting. And it's particularly exciting because the way I achieved a spinning polygon this time is unlike any other method I've ever used before. This is the best method I've used ever, and I want to show you that. But before I show you that, I'm going to talk a little bit about Q4OS. Okay, so I saw a YouTube video of a guy installing Q4OS within Windows, and that's precisely what I did. If you look at a few of my previous videos on YouTube, you'll see that I actually recorded videos on Linux. I was recording videos using Q4OS, and it's really amazing, and here's the trick to it. If you're using Windows 10 on your laptop and you want to try out Linux, but you're worried about installing Linux with a CD and wiping out your hard drive, or there are good live Linux distributions you can run from CD, but running from a CD is slow, or it might not have the programs you want on that CD. Well, here's your solution. Okay, so this is what I did. You download this, you install it, it asks you some basic questions like what your username you want your Linux distro to have, and you enter your password that you log in with. Okay, so once you do that, you reboot your computer. You're given an option to reboot into Windows or Linux. Now, the first time it will reboot you automatically into Linux, but after you finish the install, then it will install the bootloader system so that you can then boot into Windows or Linux, depending on what you feel like doing that day. So anyway, this has changed my life. You see, I was on Linux. Now I'm actually back on Windows again because I'm more familiar with my programming setup that I have on Windows. I've been programming on Windows a lot longer. Therefore, if I want to record a shorter video, it's better just to use Notepad++ and the environment that I'm used to, because even though I can do programming on Linux now, I have my shortcuts conveniently set up here the same way I've done for all my other Windows programming videos. So here's what I'm going to do. First of all, I always go to my MinGW 32-bit MSys installation, and the 64-bit also would work, but 32-bit is enough. So anyway, so there's that. So first I'm going to show you what it's like when I compile and run this program. Okay, and I got my nice little prompt set up there. In fact, let me just look at my PS1 variable, because the PS1 variable is the variable that determines the prompt that it gives me. So you see that? I had specifically set it up there, and all those other characters are about setting the colors of it and stuff like that. It's cool. Yeah, I like that. Okay, anyway, so let's look. I actually made a backup of all the folders in here to my external hard drive last night because I had done a lot of work. I had several different make files to update after I realized that the compile commands had to be modified because I wasn't including the math library, because I forgot and Windows did it for me. So when I compiled things on Linux, it wasn't working. So I had to figure that out last night. Or this morning. It was like 4 a.m. Anyway, that's beside the point. So I'm going to go to CDGL here. So here we are. I have several things. I have my text file compiling OpenGL.txt, and I have doc foo gl regpoly gl square and hello glute. Now the thing is, the foo directory is a lazy foo tutorial example that I compiled just to see if I can get things working. But I've taken bits of code from there and bits of code from hello glute. For example, if you look at, okay, I'm going to compile the other examples first just so you get an idea. So first, I type make here, except I just remembered that I changed my default compiling command. So this isn't going to compile, but if I do cat make file, if I do that, you'll see this. Now, I made the default one just named OpenGL, and it builds things on Linux because I intend Linux to be my main build environment, because after this computer dies, it has battery problems. This laptop is not going to last forever. Linux will be my primary way I do programming, and I'm going to have to learn everything to do the Unix way, absolutely everything. Okay, but we're going to do make win OpenGL. So when I do that, we're going to compile and run. This is the thing here. This is simply a square within a window, okay? That's simply what this is. And if I click the X, it exits, but also I can press escape and it also exits. So anyway, let's go back to the previous directory, and then it's very interesting because if you do cd dot, you stay in the same directory, but if you do cd dot dot, you go to the previous directory that you were in the top, above level. Anyway, so now let's go to cd foo and look at the files in here. And there's a bunch of files there. So let's do the same thing. We're going to make win OpenGL, and it should compile and run this example. Now this you see as a science square, and it's a slightly bigger window. Now watch this. You see this? When I press the E key, it changes the view of the square. But when I press Q, it changes the changes it to be multiple colors of a square. So in the lazy foo tutorial, he actually showed how that is. So you can have multiple colors within the same square, which is super cool. But that's stuff with shaders and advanced concepts that I haven't learned yet, and I don't even intend to learn that. I don't care about that. I simply wanted to draw a solid color polygon. So for me, the fact the other had a red square, this one it can have just a science square or any square if I change the source code. But what I'm going to do now is I'm going to X out of that. We're going to go to previous directory, and we're going to go to gl_reg poly. I just named it reg poly because it's a regular polygon. Now you'll see here, look at this. You look at this, I have 3 files in here. One is my make file, which is pretty much the same as the others, except it only compiles main.c. And then I have main.c, which is 2076 bytes, and I have glbbm polygon.h, which is 1137 bytes. And you see you could see the time last night, 340, 341, 320. That's about the time it was last night when I was working on this and I last updated it. It's very cool. So, okay, so now I'm going to redo the make win OpenGL. You see that? We have a spinning triangle here. This is super, super cool. So now it's not fancy. It doesn't do much really. It's just a spinning polygon in a certain window. Now, however, different things can happen. First of all, this one also closes with that X. But if I just redo it, I can also just press escape and it exits. It's super amazing. Let's see here. Now, how long have I been recording? I've only been recording less than 10 minutes. Okay, that's cool. I'm going to keep this under half an hour is my goal, but I want to show you what it's like when I modify the source code, because I do want to show you the whole source code. And But one thing I'm going to do is before I modify anything, I'm going to make a backup, okay? So what I'm going to do is I'm going to go to my GL folder. Notice we have a GL reg poly here, and there's also GL square here, which is basically a copy of the other tutorial that I was modifying. But I may delete that, but I'm not entirely sure. Actually, I'm just going to try something. CD dot, okay, and then we got, wait. Okay, here, let's see. Let's go to GL square. And then, okay, let's try make win OpenGL. Okay, now that happens to be a white square, but I removed the code that happens when the Q and E keys are pressed. I was trying to reduce that because that was just a necessary step. I started with the existing examples, then I started removing code that I didn't want. Then I started adding code, and that's how I ended up with Polygon. Okay, anyway, let's go back here, because what I'm going to do is I'm going to simply make a copy here. So let's do Control-C, Control-V. So now we have this. So let's name this temp. I just name it TMP, which is a 3-letter temporary thing. I tend to use 3-letter things. Oh, and you might wonder, why do I use 3-letter words like that? Okay, let's do LSL. Now, this is the base directory here of MSys. Now, notice we have bin, dev, dir, etc. Well, home is 4 characters, and then lib, and then man. Well, the thing is, Unix or Linux, its file system uses a lot of 3-letter things. So I just have a habit of doing that myself. Anyway, let's change the temp directory. Okay, so now we have the same files that we had in the other one, in the reg poly thing. I'll close this window because I don't need that anymore. Let's clear the screen here. Okay, so we know that we can compile win OpenGL. So here we have a white spinning triangle. Now I can change it to be other shapes. So for example, let's change this into a hexagon. So I'm gonna start modifying some source code here. Okay, I have so many. Wait. Where am I? Okay, GL. Yeah, I forgot. I forgot that I was gonna need my Windows Explorer open again so I could just easily double click on these files. Okay, we have 2 files here. We've got main.c and we've got glbbm polygon.h. So we've got that file open. Let's open up the other. Notepad++ is really pretty here. Okay, so here's the deal. We're including some standard library headers. We're including FreeGlue. We're including this header file that is right here. Now, I should show you the Polygon related code first, because what draws the Polygon is the primary focus of this video and what this program is about. So here I've defined, we included the math header. I've defined several attributes of a polygon. Now keep in mind that this value is meant for star polygons for doing a pentagram, but it's not currently used in this example. I only do convex regular polygons. I'll have to add a lot of code if I want to do star polygons. They're just a little bit harder to do. But anyway, we've got arrays for the points, the same as I used in my previous videos of my infinity checkerboard. I had a spinning polygon in that as well. So all these variables are the same. I took away this one, I commented this polygon color out, and that's because the colors are actually specified using OpenGL code that's radically different. So anyway, here's what we've got. We've got pi, we've got, you know, the rounding function that rounds to the nearest integer, and then we have the function get polygon points that it uses the sine, the cosine functions with the right angles to get the points of a regular polygon, and then it does some math with the points here, and it rounds them. Technically, I don't even need to have it round things. Wait a minute, why are there extra semicolons here? These are not even required semicolons. Why in the world are those there? See, this is the thing about programming. There's always something in your source code to go back and fix. Even though it doesn't affect how the program runs, that just annoys me to have extra semicolons. Okay, now here's the magic, where the magic happens here. We first, this function which calls the get polygon points function, and then we have GL begin. And notice it says GL polygon here. That's because GL begin is a function that says that, okay, we're going to begin drawing something. And GL polygon is one of the selections, but it's the most important because I love polygons, and polygon drawing is what this program does. And then it loops using a standard loop, just like my other programs do, through the array of the x points and the y points. And we have GL vertex 2f. Now 2f means there are two arguments present, two vertices arguments are given here, and there's the x points and the y points. So this is the x and y position. There are 3 and 4 dimensional versions of this function. You can also do change this to I. For example, if I change that to 2i, and then let's go back and let's compile and run this thing, you'll see it still behaves the same. But the reason that I'm going to change it back to 2f is because, let's say that later on I decide, well, how about we don't round to the nearest integer and we just use the actual floating point values as they were. Well, if I decide to make an alternate version where I leave that as floating point values, because I could leave it as floating point values instead, then it might be slightly faster because it wasn't doing any rounding. That's a possibility. So I may make a separate function eventually for that. But right now the program works, which is really all I care about, but it's still very fast. Now, here's the tricky thing. Now, I could actually make it run faster, but because I am recording a 30 frames per second video, I think I better leave it the way it is. In fact, and GLN just says that we're done with the drawing vertex commands. Okay, so that's very simple, but the complicated part is not the part about the polygon drawing, actually, because I already had the code for that, even though it is a little bit complicated. This is the main.c file, and this is where we have all the heavy work of opening an OpenGL context and setting all the variables for various things. So here you'll see that I put the resolution, width, and height of my actual computer screen's resolution here. And then notice I have 1280 and 720, but I've divided each of them by 2. Well, I could remove that part if I felt like it. In fact, I'll just show you an example. So if I remove the divided by 2 parts of that, and then I go and rerun this, the window is going to be bigger. You see that? Now we actually have a much bigger window, and so notice that the triangle is also bigger. Well, that's because I set it to be based on the current window size, technically based on the window height. So actually, you know what? I'm just going to leave it this way, just because the bigger it is, the easier it is for people to see on this video. So I'm going to leave it that way. I kind of like it that way. Now, so here's where things get interesting. So here we have to go down to our main function. So first we initialize freeglute. Our main function, the first thing we do is we initialize freeglute and say I have comments here. And then we have use old version of OpenGL because easier to learn. That's what I said. Okay, glute init context version 2.1. So we're using version 2.1 of OpenGL. And the reason for that is because it's the oldest version that actually still has documentation available on you know, the OpenGL.org website or whatever. So it's well documented. Also, it's smaller. It's easier to learn because there's simply fewer functions in older OpenGL versions. So the less there is for me to have to read to get my polygons working, the better. So that's basically it. Now we define the window I want and create it. So we're setting the, it's based on the resolution width and height. I had a formula that I had going on here, which is really cool. And then we set the window size. And then finally, this function actually creates a window, and it gives it gives the label. If in case you didn't notice it, when we do this, see it says Chastity's Polygon OpenGL. Now one thing you'll notice is that the window, although it's meant to be in the center of the screen, I ended up having to move it to get it to stay within the whole boundaries of the screen. So what I'm actually going to do is I'm actually going to do something a little bit different. For the purpose of making this video, or maybe even permanently, I'm going to duplicate this line, and then I'm going to comment out this version of it, and then we're simply going to make this 0, 0. Okay? Let's just set the window position to be 0, 0. So if I do that, then we rerun this thing here. Well, now see the whole thing actually fits. The whole window fits on the screen. So maybe I should have done that from the beginning. I'm not sure. But it's fine now. Now it works just fine. So we've got our window. It says Chastity's Polygon OpenGL. I can change the title of the window to anything I want. That's the great thing about programming. You're in control. Okay, now we do post window context creation initialization. Now here is where this calls another function which is defined earlier in the file, and if it runs into a problem, it displays it's unable to initialize graphics library. So it's very strange. But usually it's okay. So let's go to initgl. Now this this is a GL enum, and yeah, I actually don't understand everything here, but a lot of the code that was in the original initgl function from the tutorial I removed because it wasn't relevant to my particular program. So anyway, notice this. See this GL ortho? Well, I had to really look carefully at the documentation of this particular function, and I'm going to show you why. What if I comment out that function and then we recompile and run this thing? Watch what it does. Absolutely nothing. And why does it do absolutely nothing? Well, there's a big reason for that. The viewport is screwed up. See this, ordinarily the coordinates for where you are drawing 0, 0 is located at the center of the screen by default in OpenGL. This particular function, with all of its various arguments, sets it to match the way it is on my SDL program, so that 0, 0 is the top left of the screen, and then as you go down and to the right, you're going to, more to the middle, so that, going to the right is increasing X, and going Y is increasing is down. So I had to have it match the coordinate system of all my SDL and Allegro programs, because my polygons were meant for that environment. So I had to change the viewport in OpenGL to match that. So that's what that function does. So once it's back there, it works. Now here's where we initialize the clear color. So this is the color that happens whenever we erase the colors. So for example, let's change, and they're specified as from 0 to 1. So let's say that we set the blue to 1 and then do this. Notice then that the background color is blue. Isn't that nice? It's really kind of freaky. Now it's really cool, and you can even set it to various degrees. I like how that. Now if I set this, now this is the alpha. That is the, but even though when the alpha is set to 0, it's still, because it's the background color, it's still is the same result. But let's say if we wanted to do 0.5, let's make a darker blue. Okay. Oh, too many decimal points a number. Okay, yeah, that's right. Okay, yeah. Yeah, that it's very weird. 0.5f. Yeah, this is actually, I need to correct these. Okay, yeah. So now what we've got, notice this is slightly darker blue. That's because it's only half intensity of blue, where 1 is the max and anything else, is less than. So now notice something else though. We can also make it 3. But it doesn't really have any effect. Once you go to 1 and above, it's just the maximum intensity of that color. Anyway, okay, so that's that. And now this checks for errors. So what this does is this checks to see if there are any errors with the initialization of OpenGL. So then if there are any errors, it does glue error string and it prints it out. Now, technically, I could remove this if I felt like it, because I've never had an error, but if there is an error, then I want to leave that error checking code in there. Now, this is what a function is called whenever a key is pressed. And actually, there's something I want to do. So here's the deal. This function, you'll see it, now I don't know what the x and y variables are there for, but I'm pretty sure that I can't actually remove them. Like, let's say if I remove that, I'm pretty sure that it doesn't, oh weird, it doesn't, yeah, it says a warning. Yeah, because see the callback in FreeGlue, it's specified to have those exact those number of arguments. So I need to put it back the way it was. Okay. So anyway, I think the idea is that it passes what the key this press, and it might pass along some additional things like the x and y position of where a character is on the screen in a video game, for example. Anyway, I'm going to put in a printf statement here. Printf is just like the best C function ever. I still use it. I never use the whole C out and the C++ streaming things. I've used them before, but printf is just more convenient. So anyway, let's do, okay, let's start out with decimal here. So let's see, key equals that. Okay, so we're going to do that, and then we're going to do key. So let's see here. So now I'm pushing some keys. We'll see if it does anything. Then when I press escape, oh, you see that? Now that I've closed the program, we see that to the console it puts the exact numbers of each of the those keys, those specific numbers. And notice the key 27, it must be escape because it was the last key press, and that's the key that ends the program. So anyway. Okay, yeah, anyway, I want to change the source code again. Now let's say I'm going to add some code to this. I want to show you an example of adding code to this program. So, okay, and notice how it's specified in hexadecimal. Yeah, that's interesting. In fact, there's an alternate way to specify this as well. That's a weird way of doing it. Here's the way I would do it. I would simply do OX. Isn't that weird? Check that out. When I do that, it's probably going to give an error, an invalid suffix XX on integer constant. Yeah, but if you just have a single X, then it'll still do things. So let's see. First, I'm going to type HJKL and then escape. Very interesting. Yeah, so that's what we got here. But I want to change it to be hexadecimal numbers. I use hexadecimal numbers because I like hexadecimal. Okay, so anyway, so now we're going to run this program. I'm going to do HJKL and escape. Notice that 1B is in fact the escape key. So here I'm going to try something different. Okay, I wasn't planning on doing this before I created this video, but I want to show you something. This could be really cool. I'm going to start having user input stuff going on in this program. This is going to be cool. So we know that hexadecimal 68 is the key for H. Okay, so let's add something here. So let's have, and notice that it has an exit function. So we have an exit function here, and we're going to add another case. Okay, yeah, this is nice. So we have, and technically this is very weird looking actually, because I'm pretty sure that I don't even need all of those brackets. Let me look back at some previous code here. I want to look at some, because I remember when I did this. I want to just look at this source here, see how I did things, because notice here I could have multiple things here. So we can have case with a colon after the case here, and then it does things. So it can have multiple statements. Those curly braces are not actually required here. Okay, so those are not actually required here. So what we're actually going to do is I'm going to clean up this code a little bit by removing these extra curly braces. We actually don't need those. Okay, so here's what we're going to do. Yeah, this is freaky. So now let's look back here, where I'm going to add case scenarios for 6.8, 6a, 6b, and 6c. Well, oh yeah, very interesting how those are really close to each other. Okay, so first of all, key 6.8. Okay, so notice that I'm just adding. Okay, so we've got a case for. I'm going to leave spaces in this for now. Okay, so we've got a case for 6.8, and we've got a case for 6a, 6b, and 6c. Okay, so now I'm going to do something. I'm going to specify, because I have access to the whole source code here. Oh, and this is simply the display function. As I go down here, it clears to the background color, then it calls my Polygon function that draws the polygon, and then it calls glFlush, meaning that drawing commands are done to actually draw it. And then this is the main loop, and what this does is it repeatedly calls the display function, and then it changes the rotation of the polygon. Remember, the rotation, the radians of the polygon is here, and you can change the rotation of the polygon simply by updating that. So this is called constantly. And glute timer func, what it does is it calls it 1000 divided by frames per second, which is 30 in this case. And then it just calls itself. The function keeps calling itself. And I'm not even sure what the 0 is there for. That's weird. Okay, anyway, because you see, oh, frames per second is actually 60? I've been using 60 frames per second this whole time. Okay, wait a minute. Let's see here. Let's do a little comparison. So, so here's what it is at 60 frames per second. And let's see now. Let's change it to let's change it to 30 frames per second, because my video frame rate is only 30 frames per second. So let's slow this down. It might have been too fast for people to see on the video recording here. Now the polygon moves a little bit slower. So as you see though, I can customize, I can make it rotate at a certain frames per second at the exact speed that I want. So I have full control over the speed of this spinning polygon. That's a nice smooth animation too. Okay, so anyway, OpenGL is amazing. So what I'm going to do now is, you'll see, and then there's our keyboard function. I'm going to be going back to the keyboard function. Now, here's what we're going to do is, okay, after it does the OpenGL, then it sets the callback functions. You can select which functions do you want when a keyboard is pressed. It calls the keyboard function, and when the display function is display. So basically, it just does that. But of course, I also have display called here. It's weird, but now here's the thing: is if you remove the display function from here, then see no callback display callback register for window 1. So it's just a requirement. See, and I'm going to close this window again because it's annoying me the way it keeps switching to that window. Okay, so anyway. Okay. See, it gives an error when you do that. Okay, now it's working back to normal. Now let's see here. Okay, we're still recording. Okay, good. Now, here's where things are going to get interesting. So I'm going to, you see, after that, and this is not currently used. That's a whole other function that I'm not currently using. And then here is the initial state of the polygon. We're defining the color of the polygon. So let's say I want to make a yellow polygon. Well, let's just change the blue component to 0. Okay, and then let's rerun this thing. Now the polygon is yellow. See, I can make the polygon any color I want just by changing the source code. In fact, I could even provide a way for the user to change the color of the polygon. That would actually be very wild to see, but I could totally do that if I wanted to. Anyway, now, and then, you know, the radius, the size of the polygon, and the radians, the initial rotation value, and then the center is width divided by 2 and height divided by 2, because we want the polygon to start out at the center of the image. Let's change the number of sides. The number of sides defines what kind of polygon we get. Okay, so now the polygon size is 6. Let's recompile and run this program. And look what we've got. We've got a yellow spinning hexagon. It's actually super amazing. Well, what if I want, now moving it up or down wouldn't make all that much sense, although it could be done. What if I want to be able to move the polygon left and right while the program is running? Can I do that? Do I have the skill to do that? I believe so. And I'm going to test out my theory. And that's probably going to be the last thing I do in this video, because I do want to keep this video short. I hope it's not too long. Okay, anyway, because people get bored with long videos, that's why. So anyway, now, okay, the polygon center x variable, the polygon cx variable is here. So what I'm going to do is, if somebody presses the H key, which is 6-8 here, then very interesting how that is. Okay, yeah. Then it will decrease that variable. And then if they press J, well, then it's going to increase the polygon CY variable. And then if they do K, then it's going to decrease the cy variable. And then if they press L, it's going to increase the cx variable. And they all are Polygon underscore that. But that's simply to know that those variables are associated with the polygon. I use convenient naming schemes. Okay. So anyway, now we're going to compile and run this again. Let's see what it does. Is it working? I don't know if it's working or not. I am actually not sure if this is working. It does not appear to be doing anything. That's the thing about it. So I don't know if I've made a mistake in this. I don't think so. But for whatever reason, it's not working. Yeah, it's not responding. So I'm pressing keys, but it was not moving the polygon. Why is it not moving the polygon? I'm really not sure. But I do have one idea. I mean, obviously it is exiting the program when the oh, wait just a minute. I'm confused here. It should be working because, yeah, I'm not sure why it's not working. But I have something to try, because I'm just curious. See, this is the thing with programming. Sometimes things go wrong. Let's try something. Let's say, how about we don't call the timer func? Let's not call that other loop. Okay, let's see here. For whatever reason, it's not working. It's not doing anything. I don't get it. I really don't get it. Yeah, I expected it to change the polygon there. That's just weird. But for whatever reason, it's not doing anything. I'm gonna test something. Whenever you want to test, is a certain piece of code executing or not? Well, there's a way to test this. Okay, so anyway, we're going to enter a printf statement, and we're going to specifically, okay, for this one, so let's just have it print left. We'll simply have it print left when that happens. Okay, it does print left when I press H, but why doesn't it update the polygon? It should be updating the polygon, and why it's not, I can't figure out. That's something I'll have to work on figuring out, because it's just actually very strange. So yeah, we have our display function. We have, yeah, that's just strange. Wait, actually, let's try something else. So now, the polygon's, the polygon is actually not even spinning here. Oh, that's because the spinning is defined in this other function. Yeah, because my I wonder something. The idle function. Let's try something. Oh, it works. The idle function As soon as I enabled the idle function, then it started actually working. Isn't that weird? Yeah, this is very weird. I can now move the polygon. So the idle function had something to do with it. So cool. I can move the polygon now. It moves very slowly, of course, but it does work. Okay, yeah. So there has to be a certain idle function set up. That's just weird. Okay, let's try something now. So let's set this again here. So the idle function is necessary. Okay, so here we have okay, it's spinning, and let's see, is it moving? Oh, it is moving. It's actually moving. Whoa, is that cool or what? Oh man, that is so cool. That's so cool. I can actually move the polygon now. I'm not entirely sure why it works that way. That's very, very weird. Because I think, okay, because when I don't have an idle function, the idle function is called when there's no user input. When we don't set an idle function, then it's very weird. Wait a minute. I noticed something. It's moving. Oh, I can move it without the idle function. I thought the idle function had something to do with it, but apparently not. It still moves even when the idle function is disabled, because yeah, I disabled the idle function. It's very weird. I think though that when I didn't have the timer function enabled, or that, let's see. Okay, now it does absolutely nothing, because there's no function for it to use. It seems like I have to use either the idle function or the timer function for whatever reason. Yeah, that's just strange. I have an idea. Instead of setting the idle function to display, why don't we don't even need that ampersand there. Why don't I just change the idle function to be this? Yeah, we'll change this, the glbbm main loop function I wrote to be. We'll have that be the idle function. Let's see what it does. Whoa, what in the world? Is that freaky or what? See, when the idle function is set, the polygon moves so fast you can't even see it. Freaky. That's just freaky, man. Whoa. And it's very slowly moving too. It takes a long time. Yeah, that's just way too fast. But that just shows you the speed of OpenGL here. So yeah, when we set the idle function to be that, then it just keeps calling it and spinning the polygon faster than I can actually see. Okay, anyway, so in other words, we don't want to do that. We just have to make sure that something Yep, nothing happens. But what happens if we don't actually call that function with either of these? What if instead, let's try something. I'm just going to take the name of this function and we're going to put it here. Let's see what happens here, if anything happens at all. Statement with no effect. That's because I did not put the parentheses here. So we're going to call that function, And then it works. It's strange how that works, but it does work in fact. Yeah. Yeah, that's pretty freaky. So it does work. I'm not entirely sure the specifics of all this, but as you see, I enabled the user to move the polygon. And technically, if I wanted the user to be able to move the polygon faster, well, then we would simply change things. Like, for example, if we have it, let's see, minus equals 4. Let's try that. Then it will move left faster than other things. You see how it moves faster now because it's moving 4 at a time? So that's a way to get it to move faster, but 1 is technically enough. But yeah, so yeah, it's cool. Anyway, as you have seen, I have done some cool things. Let's see, and then this is plus equals 1, and then minus equals 1. I'm just going to change the syntax of this in case I change it later. Plus equals 1. So as you see here, this is very strange because it calls the main loop it's very strange here. Oh, that's weird. I called the main loop before the polygon was fully defined. Isn't that weird? But it still worked. Yeah, that's weird. Yeah, I think it should technically be here. That would make more sense. Now, yeah, it works amazingly, and I can move the polygon off the screen slowly like that. That's just cool. So as you see, I actually added code for the user to be able to change the position of where the polygon is on the screen simply by a case statement here. So all these different things happen. It works. So this is the basics of making a video game, adding user input to things. So I now have updated my Polygon program to do something it didn't do before, which is really, really cool. And this video might be longer than I had originally intended, but while I'm here, this is just amazing. Let's see. We'll change this to an octagon, and we'll change the color back to white. Okay, now what happens if I take away the glute main loop function? Now for whatever, when you remove that function, the program, it starts but then it closes quickly. So this is actually required here. There's like, this keeps the program from closing until you want it to close. I have an idea. I actually have a really cool idea. Wait. Okay, I need to go back to recompiling. I was just running it. Okay, so here's a really freaky idea that I have. What if I want the user to be able to change the colors? There's an easy way for me to add this into the code. Although first I want to test something. What happens if I type caps lock and then HJKL and then caps lock again? Then we get 48 instead. So you see, oh, it's very strange. Yeah, it actually works. So let's type the the H key, lowercase, and then holding Shift and pressing H, and then close. You see, the number we get depends on whether we're doing capital or lowercase. That's actually really freaky. So this gives me an amazing idea. I have this really cool idea. I'm going to allow changing the colors. And we're going to set up, okay, we're going to set up specific colors for the polygon. So we're going to start out by pressing, okay, so 1, 2, 3, 4, escape. Then we get 31 through 34. Well, actually, this is hexadecimal, so it's actually more than that. But it's 31 through 34. Okay, so here's what we're going to do. We're going to start changing the colors based on these types of things. Okay, so I'm going to temporarily put this here. Okay, so let's just put a space here, because what we're actually going to do is, okay, we're going to copy this break statement, and then we're going to put it there, and then let's do case 31. Okay, yeah, this is really nice. Well, not, why do I keep calling it 31? Okay, so we're going to make this color, when this key is pressed, it's going to change the color to blue. Okay, and let's try adding one more color here. So then, when we, okay, we'll add these other cases here. We'll just add 4 cases here. Then if it's 3, 2, 3, 3, 3, 4. So this one, the color will be green, and in this one, the color will be cyan, and in this one, the color will be red. Okay. Okay. So this will probably be the final test before I end this video. Let's see if it works. What? Wait a minute. Function. Oh, expected. Oh, I didn't add my colons. You're supposed to add the colons in after the case statements. Okay, so, and there's an extra semicolon. Why? Why do I do this to myself? Okay, let's try running this again. We've got blue, green, cyan, red, and I could add other colors to other keys. Whoa! Whoa, isn't that, whoa, I can change the color of the polygon to whatever other color I want just by setting up a certain key for a certain color. Now this saves me the trouble of having to set up a separate color palette and other key that cycles through them. Instead, I can just tell users, oh, you press this key and then it changes it to this color. And I'm going to have 8 colors supported here. Oh, that's just great. That is beautiful, I tell you. That is just beautiful. So now, as you see, it works. My program actually works. I modified the source code a lot to add that user input, and I tried to go through the whole program, as you kind of saw. So it's kind of weird because technically, wait, there's just one more thing I'm curious about. So we see here that this function is called here. But I wonder what happens if it's called after a glute main loop. Let's see here what happens, because I just am experimenting with this program. Oh, you see now? Now it doesn't do anything. Yep, that's because it goes into the main loop, but it doesn't run my customized code. So you see this main loop, my own main loop. So it works. It actually works better than I had ever thought it would. That's just great. It's great, man. And now, just for an example, also, what happens if we remove the glute timer func from here? Because the function calls itself here. And you see when we remove that, the function no longer calls itself. And there has to be a repeated calling of this function by itself. Oh, and I just thought about something else. What if the function calls itself with no delay? I'm toying around with this just to trying to see what happens. If it keeps calling itself, it calls itself, but nothing actually happens. How weird is that? So in other words, this has to be called. Yeah, it has to be called, but then it has to be called with a delay. Otherwise, without the delay, it doesn't allow the user to change things with the keyboard. So, amazingly, it works. So here I have a spinning polygon example that the user can move around by holding a certain key, and it slowly moves the polygon. And I can also change the color with these keys. So this is my OpenGL polygon, and I can do all kinds of crazy things with it, whatever I want. So in the future, I plan to add code to start like drawing checkerboards and other stuff as well. But anyway, yeah, I hope that somebody has enjoyed this demonstration of my OpenGL skills. I'm learning OpenGL, and Glute, or FreeGlute as I'm using, is the OpenGL utility library. It's an open source, so it's FreeGlute. So yeah, basically it's a utility library that lets you access OpenGL functions. You have to create a context, you have to set. So the names of the functions, what they do, I've spent hours reading this stuff. I'm really tired from it. But that's what I did last night. I was working and I got the spinning polygon working, but now, while I was in the process of recording this video, I learned how to add other user inputs and change the colors. So I'm learning even as I go and even as I show off my program. So anyway, this video has been long enough, but as you see, I am learning OpenGL and I am very happy with my progress so far. See you in the next video.